All right. Oh, I gotta click the other button here, right? So you can see my screen. How's that? All right. Happy Monday. Sorry. Oh, good morning. Hopefully your Monday is going better than mine, but we got here, so that's progress, right? We're starting a new topic today. Super excited to get to the next chapter in functions. This is one of my favorite chapters. I know I say this about like almost every chapter, but functions are one of my favorites. So we're going to spend 2 weeks here on functions. By the end of next week, you'll be tired of them, but it's okay. It's good. We're getting some practice in. We'll do a bunch with them. We'll work on a lab today with functions. Next week, we'll have another lab on functions. Project 1 is due on Wednesday, right? So if it's not done yet, get it done, right? Ask me questions. Let me know how I can help. I'm not going to tell you to go away. I'll get you pointed in the right direction. Unlike the labs, though, I won't solve it for you. Right? I'll say, oh, hey, you want to use this thing? Go look this. Go look at more of these things. That sort of example stuff. I think I showed a demo of the output for you guys. Did I do that? Of what the output might look like when it runs? Yes? No? Someone said yes. Okay. Other people look funny. No? I don't remember now. For what it might look like when the program runs. Just one way of, hey, this is one option for how you interact with it. On my example, I used strings. You can use a number menu. Any sort of menu you want to come up with is great for user input. Right? Whatever makes sense to you will get the job done. Right? Numbers are pretty easy, like 1 for this, 2 for this. Now, when you've got like 7 different options, though, it's kind of annoying. Like if you ever listen to one of those phone menus, press 1 for this, press 2 for this, press like sure, whatever. But totally options, right? If you want to do strings, great. If you want to do numbers, great. Either's okay. So that's due Wednesday. I'll go over the solution on Wednesday, how I would build it. Again, just one way of building it. Yours doesn't have to look the same. I just want to show you how I would approach it, kind of piece by piece by piece, trying these things out. That's the problem-solving skills, ideally, that we're learning, right? How do we approach a big problem, break it down into smaller problems, and solve the small problems a little bit at a time? This iterative development process, right? To make sure that the little bit I do works, and then write a little more, write a little more, write a little more, write a little more. That's ideal, right? And that's hard to do when you do big projects sometimes. So we try and tackle what's the small piece that I can handle, right? A little bit at a time. And we're going to get more into that as we talk about functions, because functions are amazing. Okay? Thoughts, concerns? We okay to get going? Let me fire up Visual Studio. I did get a new laptop. I'm super excited. But I did not install Visual Studio on it yet because I wanted to play games instead. So I installed all the games first. Because this laptop won't run my games and I'm sad. So got some games running. It's nice to be able to play Diablo 4 again. I got to get into Baldur's Gate. It came out when I had this laptop and I was so sad. So my son's been playing it on his laptop. But all right, so I'm going to do the console app again. It does a couple extra things for us, which is great. Right? It's nice to go from the empty so you know what all the steps are, but this one really saves you a lot of time if you do the console app. And we'll call this one Chapter 5. This is functions here, and I'll create it. Now, we've used functions. So this chapter, the focus, or what Zybooks names it, is user-defined functions. I'm going to get rid of all this garbage here. We don't need any of that. And then I'm going to include, or using namespace standard. So this using namespace standard means you don't have to say standard : before all your couts. So this is a handy shortcut so that you're telling C++, hey, every time I say cout, use the one that's in the standard namespace. Right? I don't know of any other couts at the moment, so I don't know why. It's silly that's not always using standard, but sure, why not? And then again, you can use the \n for new lines if you want. I'm more fond of the end lines myself. Just having to type \n is annoying and see it. I don't know. So I prefer this, but they both do the same thing, right? We'll both go down a line, and eventually we should return 0. It's slightly more proper. It'll basically happen anyway, but it's nice to be a little explicit here when our main runs ends here. Okay, so we've been using functions. I don't know if we knew they were called functions. We just knew stuff happened, right? So if I wanted a random number, right, we would say, hey, I want rand, And let's see, so let's just see out. You should buy a lotto ticket with numbers, and we'll see out a bunch more of these random numbers here. So Powerball is 1 to 69, right? 1 to 69 plus 1, and we want that 5 times. So rand here is a function. Rand is giving me a value. I'm taking the value it's giving me, and I'm doing some arithmetic with it and throwing it in here. So we can, let's actually make a loop here because this feels silly. So we'll say for int number is 0, number is less than 5, number plus plus. Right, do a little loop, and then we can see out the random value 5 times, and probably a space in between each of those, right? Between all the numbers, and when that loop's done, then we can see how there's also the Powerball number, which is, what is that, 1 to 26, I want to say? 26, 36, I forget now. And I don't know, we'll say Powerball. We'll look it up later because it's for the next project. It'll be a lot of fun. Rand mod 26 plus 1. And that one we can put in that line. We probably don't need the hello world anymore. But rand is a function that is giving me back an integer. Right? We know it gives us an integer. If you hover over it, it's not the most helpful here because there's some other garbage in here. It says int underscore CDELC. I don't even know what that means. Rand. It's saying this function will give you an integer back. Right? Well, we were dealing with characters and using single character input at a time, right? Enter yes or no. We said, hey, we'll have a char for play again equals a y, right? And we could say while play again equals a y. Let's do something here, right? And we probably get their inputs. Yeah, if you want to play again. Can't type here. Not had enough coffee yet. And then we could see in to play again. But I don't want to just compare this character that was entered because sometimes users have used capital letters, right? So we said we could use, was it 2 lower? Now, 2 lower, when you hover over it, has a couple more pieces of information here. So it says int, this CDELC, I don't even know what that is, 2 lower, int underscore C. So this function, 2 lower, takes an integer, which is, characters are really integers. That's behind the scenes, thanks to the Unicode table and things like that. And it gives you back another integer, which is, again, we're using as a character. So we can see this, if you give it an integer, we'll give you back an integer. Cool, we can do that. Right? I think we did the rounding here with the math library. We included math. Include math. So was it CMath or Math H? I think they both did the same thing for us. I forget which one was which. Right. We said, hey, let's round a number. Right? Because it was very interesting. Pi rounded up is, and we said math.seal, was it? No, just seal. And seal now, we get another piece of information. We get this little thing that says 1 of 4. You can give it a double, we'll call it x, and we'll give you back a double. You kind of read these inside out, right? What you give it inside the parentheses is what it wants, and then what's here is the value that comes back out. So if you give it a double, it gives you a double. There's another option. You can give it a float, it'll give you a float. There's another option. You can give it a long double, it'll give you a long double. Those are really big numbers. My goodness. And you can give it something here. I'm not even entirely sure what that is. You'd have to go look it up on c++.com. But eventually you get back a double of some ty, sure, something. So if I give it a double here, like 3.14, I'll get back a double. And now that I put in a value here, when I hover over it, it says, hey, this is the one you're using. It knows that, which is pretty cool. Right? So those are all functions we've been using. But these are built-in functions, or functions in libraries here that are available to us. What we get to do now is we get to write our own functions. And this is where programming gets to be a lot of fun. So a couple things about functions, right? There's a couple really good reasons to use functions, right? Probably the first most important reason is it lets us not repeat code. Because remember, anytime you have the same code in your program twice, you feel bad about yourself. We don't want to feel bad about ourselves, right? We don't want to have to repeat code. I want to type it one time and use it over and over and over. So how do I generate a random number? Well, this is actually a bunch of code behind the scenes, right? I don't want to have to use that bunch of code. I could go find it, right? We could look up what it does and copy paste in those 20 lines. That's really obnoxious, though, to have here's the 20 lines, and here's 20 lines, and here's 20 lines every time I want a random number. So it lets me use some code without having to write it more than once. So if we wanted to write our own functions here, we can write our own functions. So now we're going to come outside of this int main. So int main is a function. We just never really called it that. It's the main function. So this is where everything starts in a C++ program. It has to have a main to start. If there's no main, it won't start. You can't run it. So everything starts in a main function here, but we can write functions outside of main. So no longer inside the main set of curly braces, we get to write our own functions. Now, two kinds of functions of big grouping here. There are functions that return values, like this is going to return an integer at some point, rand will give you back an integer at some point, ceil will give you back a double, right? They are returning values. So they give you something you can use. You can also have functions that just do something. They're void functions. They don't return any values here. So if I want a function that just does something and doesn't give me any values back, we can also do that. So I can say, hey, this is void happy Monday. Monday. And then it gets a set of parentheses and then a set of curly braces. So this is return type or void. Oh my goodness, that's Python. Return type or void. And then we get the name, function name. And again, it follows this camel casing style generally. Right? Start with lowercase, every next word gets a capital letter. Right? The function name, and then we get parentheses. So return type or void, function name, parentheses. This is where you can put arguments. Like when you call rand, you don't have to give it anything. You don't need to tell random anything to get a random number out. But if you want to get a lowercase letter, you have to give it an integer. Because otherwise, what letter would it give you to lowercase? Right? You have to tell it, this letter, please, as lowercase. So you can put things in as arguments here if you want. They're optional. This is optional arguments. Right? And then you get the set of curly braces. So we're defining the scope here. We talked a little bit about scope. Variables that are created inside of this function only exist inside this function. You only have access to them inside this function. Right? Just like if we were in a while loop or a for loop or something here, the variable created inside this code block only exists inside that code block. Right? Like we talked about with loops, so same thing applies. So maybe this one just says, hey, I want to see out happy Monday, end line. Now this is a little silly here, but inside of the rest of my program now, I can go and say, hey, you know this thing I called happy Monday? Run that, please. So I can just say happy Monday, and I can say happy Monday, and I can say happy Monday because it's a super happy Monday because I made it here. It's very exciting. Much better than the days I don't make it here, right? So I don't have to repeat. I mean, this is only one line here, but maybe I'll say, hey, see out. What else should we say in happy Monday? Say we need more coffee. Okay, so happy Monday and we need more coffee. So now I have two lines of code that will run every time I call happy Monday. So when I say happy Monday, it will jump to the happy Monday function, run start to finish, and then come right on back. So what's fun here, I can put my breakpoint in, and if I run this in debug mode, we're gonna stop and see how it knows where it is as it's running. So, no more coffee. All right, so we're ready to run line 15. Okay, this is where C++ is ready to execute. Now, before when we did debugging, I said most of the time we want to step over. Well, now we're changing that. So this is a function. If I want to go into the function, I want to step into. If I just want it to run and just go to the next line, I will step over. So step into will go into my function. So I'm going to step into. So now it says, oh, sure, now I'm at line 8. So we've essentially jumped. So it used to be, hey, you would run this line, you run the next line, you run the next line, you run the next line. And then we said, oh, we can do if else's. So maybe you run this line or maybe you run this line. Sure. And then we said, hey, we can do loops. So run these couple lines and come back to the top. run these couple lines, come back to it, but it was still always one line, next line, next line, next line, next line. So now we're able to jump, essentially. We'll say, hey, remember you were here at this line, but now go do this other thing and then come on back. And the way that it tracks it, in your debug view, it's a little hard to see here. This is the call stack. So it says, hey, I was at line 16 in main for the chapter 5 functions.exe. Now I'm at chapter 5 functions.exe, happy Monday, line 8. So this is the call stack. So when you call a function, it gets put on this stack of function calls. So that when this is done, it knows, oh, okay, you're done. Now I can come back to where I left off here at line 16. Right? It's essentially like left a bookmark here. So, okay, I'll come back to this when I'm done. Right? It's like when you read those choose your own adventure books and you get to where you died, you're like, oh, let me go back a couple choices here. You gotta leave the bookmark there. Yeah. Yes, so functions are defined outside of main because main is itself is a function. So new functions that we write are defined outside of main. Yep. So now this will step. Now I can step over here one line at a time. There's nothing to step into really. And we'll see in our output here, happy Monday, we need more coffee. Now we're at line 11, so when I step again, it comes back to line 16. Right? It comes off the call stack. I said, okay, that function's done. Now I can step in again if I want. We'll come back to here, step over, it does these things. Now we're gonna come back to line 17. This time I'm just gonna step over, I don't wanna watch all that happen, right? And it just goes to the next line. So if you want to see what's happening in your function, step into. If you just want it to run, step over. And those are our options when we're debugging. And we see 3 times now this was repeated because I called it 3 times. Excuse me. All right, we can stop that for now. So this is a void function, it's not returning anything, it's just doing some code. That's all it is. We can also write a function that accepts arguments. So the technical term here, they're named 2 different things, and it always confuses me. Pretty much everyone in the world understands that the words are used interchangeably, but if you want to be technically correct, we can do that. So we'll say this is a void happy day, and I want a string for day. So to call the happy day function, you have to give me a string I'm going to call day. So right here, I have defined a parameter. So the technical term here is parameter. I call them arguments. We'll talk about that in just a second. So if you want to call happy day, I can't just say happy day, parentheses. It's going to yell at me and I get a red line here. It says too few arguments in function call. I didn't give it a string. So you can't call the happy day function if you don't give it a string. Right? Just like we can't call toUpper, we can't just say toUpper if you don't give it an integer, right? Too few arguments in the function call. There's nothing here for it to work with. So when you define a function, you can't use it without giving this value here. So in here we can just say Monday, right? Sure. And then we can do this exact same thing if we want here. We'll say happy, and then instead of Monday here, we'll put in the day. So inside of my function now, I can use this variable name because I know it has a value. I don't know what the value is. It's variable. Whoever used my function happy day gave me some string. I'm calling it day. They could have given me the word apple. They could give me the word Eric. They could give me the letter A. Right? If it's a string, my function will take it. But hopefully they gave me a day and it will make sense in this output here. Right? So this is the parameter. When you pass something to a function, you're giving it an argument. And that's the technical difference. So when you're giving it a value, you're giving it an argument. In the function, it's technically a parameter. I don't know. Some people like to argue about stupid things. So just acknowledge we know functions or arguments and parameters are pretty much the same thing. I call them arguments everywhere, right? But it's technically a parameter here. So sure. Everyone else will be okay with it, I promise. It's no big deal. Okay, so you can have something required to be given, and you can have more than one thing. Right? You can have multiple arguments here. Now, I'm trying to remember if we've done anything with multiple arguments. I don't know if we have or not, but we can write one here. So let's say this is void. What do we want here? How about if you're happy and you know it? Right? So we want a string for the action. Right? Do you clap your hands, or do you stomp your feet, or do you shout hooray? Something like that. right? And then we want an integer for the, what is this? Is it like the first verse, the second verse, the third verse? Is that what those are? The first repetition count? I don't know. Verse number. I'll just say verse number here. Okay, so you tell me what the action is, and you tell me is this the first time, the second time, the third time, something, something, something like that. So if you want more than one parameter, more than one argument, you just comma separate. Right? So we can now say, you know, if you're happy and you know it, and then we'll add the action here. But we only really want this if the verse number is less than 3, then we want that. Right? Otherwise, we want to say if you're happy, you know it, and you really want to show it. Can you tell I have small kids? I hear this song all the time. It's on my mind right now. Here's the action. Right? That's getting a little long, so let's move it down here. Goodness. Nope. That one. That one. Okay. And we probably need some end lines in here too. Oops. And an end line. And one more end line. Okay. It's a little long, but you can see most of it, right? And if you're not super zoomed in on your font, you can probably see it a little better too. So we can have more than one argument given. So you just give it multiple things. You can have a bunch of these. Now, if you need like 7 or 8 arguments, it's a little crazy. You can, but that's just going to feel really awkward here. So you can though, right? So this is a way to say, hey, let's ask for a bunch of values to be given to us, and then do some code. Now again, these are all void. They're not returning anything. So I'm just calling it here. So if you're happy and you know it, I want to clap your hands. And this is the first one, right? And then we can do it again, 2, and again for 3. Now I feel a little bad. We could do a loop here. Yeah, let's do a loop here. So we'll say for int versus 0, I guess 1, right? And versus less than or equal to 3. You can do your loops any way you want here. No biggie. Verse plus plus. And then we can call if you're happy and you know it and give it the verse. All right. So we can call our function 3 times, 1, 2, and 3. We should get this one, and then this one, right? The code does the same thing. We've just now put it in a function. So you don't have to have the same idea more than once, the same code more than once. The other really cool thing about functions, another great reason to use functions, is you're putting a name to what's happening, right? If you never even look at the code, like the only thing you look at is main, you can probably get a guess of what's happening in these functions just based on how they're named, right? We're putting a name to what's happening. So it's a way for us to take a big problem and break down smaller and smaller and smaller pieces of it and put some names to it, right? So this one is not necessarily the most interesting problem to break up. But what if we were to play like rock, paper, scissors, right? There's a couple things that happen in rock, paper, scissors. So instead of having everything in main, if I just want to say, hey, what are the main steps that happen in rock, paper, scissors here? Well, the first thing we have to do is we have to get the user's throw, right? So we can say, hey, I want a string for the user's throw is equal to get user's throw. Right? Again, I don't have a function here yet, but we'll come back here and we'll do that. So I can just say, hey, let's do a couple steps here. And then maybe we have a string for get computer throw, or computer throw. Throw is equal to get computer throw. And then maybe we have a, I don't know, display winner. Winner given the user's throw and the computer throw. Should be on S, probably computers throw, users throw, sure. Right, so like the 3 things that happen are we have to get the user's throw, we have to get the computer's throw, we have to figure out do you win, lose, or draw. So I can use functions here. Now I'm not getting the user's throw multiple times, I'm not getting the computer's throw multiple times, I'm not displaying the winner multiple times. I'm not really saving any code here, I'm not avoiding repeated code, but what I've done is I've broken down a big problem into smaller problems that I can solve individually. There's a really fancy technical term here for this, it's called functional decomposition. One of my favorite technical terms of all time, because when you use it in the conversation with someone who's not a programmer, they look at you like you're nuts. It's like, who says functional decomposition? So if you'd like to, when you go out and talk to people who are not computer people, throw it out in a conversation and see what they like, what kind of reactions you get. Now, I do this all the time because people know I'm weird, and all the people I interact with know I'm just a crazy programmer person. So they're not really surprised anymore. Then they expect me to say weird things because I like to do that because it's funny. I don't know if everyone in your circles knows that you're a weird programmer person. Does everyone know that yet? Or eventually they'll be surprised. So try it. I like doing this at Thanksgiving dinner with the extended family. Like, man, I was so busy doing this functional decomposition. I'm so tired. Everyone's like, okay, you're just being Eric again. Sure, that's fine. So give it a try. It's kind of fun. But the whole idea is we take the big problem and decompose it down into smaller and smaller and smaller problems that we can tackle with one function at a time. Right? So to get the user's throw, now this one I'm saying, hey, I want to assign to a string. So it's not going to be a void type anymore. I want something that will return a value. So I'm going to say, hey, this is a string type. I will give you back a string for get user's throw. I don't need any arguments or parameters, right? I know it's rock, paper, scissors. Sure. So we can ask the user, right? We'll say enter rock, paper, or scissors. And then I can have a string for their input maybe or something, their choice, or how about their user's throw? Sure, why not user's throw? And then I can see in the user's throw. Now I can even do the validation bit in here, right? I can say while my user's throw does not equal rock, right? And user's throw does not equal paper. I guess, should we lowercase all these? We should lowercase them all. Rock, paper, scissors. And my user's throw does not equal scissors. Let's keep on going here. So if I want to save myself a little bit of time here, I'm actually going to put the prompt inside here. And I'm going to start user's throw at something that is not rock and not paper and not scissors. So here's my throwaway value so that my loop runs. Now, some people might say, hey, I should just use a do loop, which is fine. That's proper. I just hate do loops. But that's really the only reason, right? So I'd rather do this than use a do loop. So I'll set user's throw to something so I know the loop will run, and then I'll ask them, enter rock, paper, scissors. If it's not rock and it's not paper and it's not scissors, we keep asking again. Eventually now, how do I give it back? Well, there's a new keyword. We're going to use the word return. Notice we had return down here below. In main, we returned a 0. So return says, I'm going to give back a value to whoever asked for this function to run. So I'm going to return the user's throw. It's a type of string, so it matches. I'm going to give it, I said I will give you back a string, and I'm going to return a string. You can't return 0 here. Oops. Right, C++ won't let you return 0. Not going to work. Shouldn't work, right? So, but we can return a string because we said we'll give you back a string. Okay, so that's my user's throw method. Right, get computer's throw is a little bit different. So this one again will return a string. This will be get computer's throw. Computer's throw. Yeah, we'll add an S there. Get computer's throw. Now this one was going to be random. Right, let's pick a random number. Now to do random, we had to actually include? Is it time? Isn't it the time module or something? I think it was time. I can go look at the other one, but you have to seed the random value generator with time. This srand, time of 0, right? Yeah. So I say, hey, let's give it a seed value here so that your pseudo random number generator looks like it's actually random. Right? If you skip this step every single time you call rand, you'll get the exact same sequence of random numbers because it's not actually random. Computers can't do random things. Basically. So we'll do that. Then I can say, okay, now let's say, how about if my, do you want to do I hate switches. So we'll say, here's an int for computer random, I don't know, a random throw is rand, and we want to do mod 3, so I get a 0, 1, or 2. Right? And I can say, hey, if my random throw, oh my goodness, sorry. Oh, my. Whew. So if my random throw is equal to a 0, now you've got a couple choices here, a couple different styles. Some people like the style of here's a string for computer throw, and then I can say, okay, if it's 0, can my computer throw throw is equal to rock this way. Sure. And then we can say else if my random throw is equal to a 1, my computer throw will equal paper. Now, I don't need another if here, right? This is just an else, because I know if it's not a 0 and it's not a 1, it's got to be a 2, right? That's just, I know that. So you don't need else if again. Right? Save yourself a little bit of time here. When all of that's done, then we can return the computer's throw. Some people like a single return at the end of their function. That's fine. It's nice and pretty, nice and clean. You can see at the very end, we're going to return computer's throw. That's okay. Generally, I like that as well. But this one is pretty simple. We could, if we wanted here, have inside of here return rock. And inside of here, we could say return paper. Paper. And inside of here, we can return scissors. So you can have multiple return statements inside of a function, but one and only one of them will run, because if it's an if, else if, else if. It's a chain of mutually exclusive if, else if, else if, else ifs. That's still going? Okay, the other monitor just turned off. So just a style preference. Some people like a single return. Some people say, oh, sure, I'll just put a couple returns here. Again, whatever you think is going to be readable. I think this one is close enough, pretty simple, that you can have a couple returns here. Generally, though, I like just a single return at the bottom. Right, so I'm going to leave these commented out here, just that's an option. Right, so there's nothing wrong with having more than one return, but as soon as you hit a return, what do you think happens to the rest of your code in the function? It's done. It doesn't run. Like, as soon as you find this return keyword, the function stops, because the return says, function, you're done. Before, with our void functions, they weren't done until they hit the last curly brace. With the return keyword, as soon as it finds a return, it's done. It doesn't matter if you have code that comes after it. And generally, it will warn you here if you wanted to say cout function still running. I think it'll warn you that it's not accessible here. Oh, I got to finish this other one here. So let me put in one more function here. I think it should warn us. Usually does. So the display winner, we don't need to return any values, right? This is just a void function. It's just going to do something. So this is display winner, given a string for user's throw, and given a string for computer's throw. Okay, now is it going to warn me? It's not going to warn me? Really? Most good compilers do that. No? Okay, so it's not going to warn you here. So this code will never get here. Never get to this line. Right? Because once you hit return, you're done. Function's over. So having code after a return, pointless. I really thought it used to warn you. That's weird. All right, and then for display winner, right? Again, this was win, loss, draw. So draw is the easiest one. I can quickly say, hey, if my user's throw is equal to the computer's throw, computer's throw, there it is. We can cout draw. Right? Then I have to look for the other conditions, right? So else if, okay, well, what's a win condition? If my user's throw is equal to rock, and my computer's throw is equal to scissors, right? That's one possible way to win, right? Or my user's throw is equal to paper, and my computer's throw is equal to rock, right? That's another way to win. Or my user's throw is equal to scissors, and my computer's throw is equal to paper. Now, hopefully you're thinking this is kind of ugly and very error prone, right? These are not exactly magic numbers, but the chance that I'm typoing scissors is really high, because spelling scissors is not my strong suit. I mean, I can usually get rock. That's 4 letters. Paper's only 5 letters. Scissors has double letters. It's 8 letters long. Like, this one's a hard one to spell. So it's very error prone. And if I typo it somewhere and I don't notice it, I'm going to be in big trouble. So it might be nice to have some constants for these. Right? You're all thinking, yeah, that's a great idea. Why don't we have some constants? So we could add some constants. Now, let's see. Oh, I never finished that. There we go. So that's the win. You can cout win. Player wins. Player wins. and then line, and then we'll just finish that. If you didn't draw and you didn't win, and see out, player, you lose. Player loses. Sure. Well, that's a rock, paper, scissors game. So if I want to have some constants, we got some choices. Right? Before, we were defining everything in main. If I define a constant in main, constant string rock equals rock, or I don't know, all lowercase, right? Sure, but now can I use this rock variable somewhere else? What happens to the scope of rock? Right? Its scope is main. It only exists inside of main. I can't use it in display winner. Right? And I might even want to use these in my other places. Right? Because I have, if it's not rock, it's not, I have these same variables lots of places. Right? So what we want to do is we can have variables that are not defined in a function. I can say, hey, here I really want my constant string for rock equals rock. So these are defined, it's the scope here. I'm trying to remember. I think this is global. There's a word for it. I'm sure it'll come up in Zybooks here in a little bit. I just don't remember off the top of my head. So if you define a variable outside of the function scope, you can use them inside. Remember that the bigger scope is accessible inside the smaller scopes, the more narrow scopes. So this is a bigger scope at this file level. I think it's global level, but we'll figure it out later. Constant string for paper equals paper, and a constant string for scissors equals scissors, right? So now I can use rock, paper, and scissors everywhere in here, and it's much cleaner and much less likely for me to typo it here, paper and scissors, because now I get the IntelliSense type ahead, right? I just need to use my variable, and if I typo this one, it's going to tell me that variable doesn't exist, right? If I miss an S here, it's going to say I don't know what this variable is. Identifier scissors undefined. I spelled it wrong, right? So then I can replace all these here, rock, and paper, and scissors, right? And then if it's rock and it's scissors, now it'd been nice if I'd done this earlier, but that's okay. Right? Paper, rock, paper, and scissors. You'd be amazed how many bugs there are from people who typo things in strings. Like it happens a lot, because I mean, just like when you write an English paper, right? You know what you mean to say. It's hard to catch it sometimes. So I think we replaced it with most of those here. Okay so far? So we've done some functional decomposition on our rock, paper, scissors game. Now I guess we could put all of this then in that do you want to play again? Here would be fun, right? So we don't need the constant here. I'm going to get rid of that one. Let's do all this in the do you want to play again? Right? Now another thing we can do, because again, why do something on 3 lines when you can do it in 1 line? It gets a little ugly, but you might see people say, okay, if the only thing I'm doing with this user's throw is handing it here to display winner, I can pass this function in as the argument. This is where it gets a little crazy. So let me undo that. I'm going to comment these ones out here. No, it's right here. Thank you. Right there. Display winner. And I'm going to say, hey, I want to display winner of the get user's throw of the get computer's throw. Get computer's throw. Because remember, order of operations applies. So the things inside the parentheses run first. So this will run first. It will give back a value. I don't need to assign it to a variable because I don't care what the user's throw is aside from giving it to display winner. Okay, so this is sort of like a shortcut. I don't need to use that anywhere ever again. So I'm just going to call it right here in display winner. And again, you can basically just with looking at this one line, it might take half a second or 3 seconds or 5 seconds, but you can see what's happening here. Well, I'm going to display winner of the get user's throw, get computer's throw. Okay, sure. This might be a little more obvious, right? So there's nothing wrong with doing it this way, but people love saving lines of code for some reason. I don't know, it's satisfying, I guess, sometimes, but so you might see it like this, you might see it like this. Either way is okay. It's not going to hurt anything one way or the other. Right? And then do you want to play again? We go over and over and over again. So I haven't actually run this yet to see if it actually works. So let's give it a try. Let's see if it actually works here. It's been a little while since I ran. All right, so to get rid of the breakpoint, you just click on it again, or you can hit continue, it'll run to the end. So it finds the next one. All right, so more coffee, more coffee, more coffee, more coffee. Happy Monday. If you're happy, you know it, clap your hands. If you're happy, you know it, clap your hands. All right, buy a lotto ticket. We didn't check for duplicates. Be careful, in Powerball, you can't have duplicates. That's a whole other thing. Don't worry about it, because it's in combination, not permutation. But okay, go take your math classes. All right, so rock, paper, scissors. Which one should we play? Again, my strategy is always play rock. Did I tell you that? Okay, it's good. So let's play rock. Oh, we drew. Let's play again. Rock. We win. See, my strategy works. We faked the computer out. This computer's so stupid. And pi rounded up is 4. Are we okay so far? All right, so let me go ahead and commit this to GitHub here. So here's the start of functions, right? So we have functions that return values, value returning functions. We have void functions that don't return values. We have functions that take arguments, functions that don't take arguments. Right? Any combination of those are great. Whatever you want to do here is perfectly fine. We're avoiding redundant repeated code, so we don't feel bad about ourselves, and we're putting a nice name to what's happening. Right? I didn't save any code with rock, paper, scissors here, but what I've done is when I look at the main method, main is a lot smaller because I see, hey, I'm going to do this thing, I'm going to do this thing, I'm going to do this thing, which is nice. So I can quickly just kind of skim through, this is what's happening. If I want to know the details, then I can go look at the functions. So as your programs get bigger and bigger and bigger, it's really nice to have a very clean main method. So you can just quickly skim and see, okay, it's going to do this, and then it's going to do this, and then it's going to do this. And if you want to know what those specific things are, you can go look at those functions up. Now, as our files get bigger and bigger and bigger, it's kind of annoying to have to scroll up and down and scroll up and down and find these things. And we're at 124 lines or so, which is small relatively compared to as big as we're going to get. So it's kind of annoying to navigate around. But yeah, global scope. Look at that. This is the global scope. It's even telling me here. Visual Studio is amazing. This isn't. It's global. I had it right. Sometimes things are in my head correctly. It's amazing. So if you want to be able to like jump around here and see, oh, let me go find a function, I can click this drop down here, and it gives me the list of all the functions, and I can jump to any one of those functions here. So don't just scroll up and down looking for it. I mean, you can, you're welcome to do that, but if you want to get into the habit of using the tools to save you some time, go pick your function drop-down list. It will go find those functions for you, which is really nice. So you can just say, hey, I want to go find one of these. Now, I'm not in a function right now, so there's no function because I'm in the global scope, right? If I go jump down to one of these functions here, then I see I'm in the get users function. As I click around here, right, it changes the name of the function I'm in. I don't know if you've noticed it was changing here. Probably not. There's tons of things on this screen here, right? This is kind of fun. So the tools will help organize things for us. Different people have different conventions around where, like, the order you should put your functions in, if you should alphabetize them or things like all that sort of stuff is really annoying here. I don't care too much one way or the other for it. Now, I think C++, let me double check here. It's been a little while since I tried C++. I think when I do this, does it work? Okay, good. So the order here is not important. Oh, no, now I'm getting build errors. Yep, okay, I lied. This is what I thought. I wasn't an error before. So the order is important because C++ is dumb and it reads the file from the top and on down. It doesn't read the entire file. So it starts at the top. If the first thing you get to says, hey, I want to run this Happy Monday function, if it hasn't already read a function named Happy Monday, it says, I can't find Happy Monday. I don't know where that is. So your main method is always going to be at the bottom because all the other functions have to be read first for main to work. So let me go put main back at the bottom here. There it is. Now it'll work because it knows where the functions are. So when it reads the file, it reads top down. It reads, okay, here's a function, here's a function. It doesn't run anything yet, but it has read it, so it's defined. Just like when you define a variable, like we said, hey, I want an int for number here, and then I can see out, or number equals 42, and then I can see out number, right? This is great, but what I can't do is see out another number, and then say another number int, another number equals 77, right? It's upset now because it says this is undefined. The same way that this works for variables works for our functions. If you haven't defined it first, C++ is stupid and doesn't know where to find it. So all of your other functions will have to go up at the top. That's all. And we'll get into other things. We got some other fun things. Functions can call functions, which can call functions, which can call functions. So the order of those matter as well. So we'll get into all that here. So order matters in variables and functions. There we go. I'll just leave that commented out. That was just our example here. All right, so I'll go ahead and commit this code to GitHub here. 50 all. So here's functions part 1. We do have lab later today, so hopefully you have a fun afternoon on campus. I don't know where you guys hang out. There is the computer lab in the CIS building. It's always very quiet there if you like, even more quiet than the library generally. I've seen like one person there all semester. So it's a great place to hang out. And I like the CIS building. I'm partial to that because that's my building. Yeah, so we'll do a lab on functions. Any other thoughts, questions, concerns? Again, sorry to be late. I'm just bad at phones apparently or something. I don't know. If it's too close to my face, I can turn it off in my sleep. So I need to keep it further away from me, but it has to be plugged in. Because if you don't plug it in at night, it dies during like the day, and it's sad. So, all right. My wife always threatens to get that alarm for me that is like, it's a little helicopter thing. And it actually shoots off and spins somewhere in your room, and you have to go pick it up and grab it. Otherwise, it's really annoying. That would be really fun, but I don't know. What do you do if it lands on your face? It's got to be sad. All right, so let me stop this. I'll post this one out on YouTube.